Okay, I don't know about you guys, but I'm dying to make some things real. So first thing I'm going to do is I'm going to go ahead and make the modifications to the devices in question. So I'm going to come in here and I said I was going to change the interface. So I'm going to say Ethernet 00, IP address 172.16.10, and I said I was going to make this one 104, I'm sorry, 101, 255, 255, 255. I'm going to say no shut, and then I'm going to say IP route, and I'm going to give it a default route, and I said I was going to use 172.16.10.1 as the default route. So we'll go ahead and put the quad 0 in here, and we should be good to go there. Let's go ahead and do the same thing on this guy. So EN, I'll say config T. I need to change duplex mode. So discover enterprise not full duplex with, so I'll say interface, just to get rid of that chatter, interface Ethernet 00 duplex full. There we go. So in here, interface E00, I'll go ahead and just say duplex full while I'm here. IP address 172.16.20, 102, 255, 255, 2550. And I said that I was going to give it a default route, IP route of quad 0. And we will do 172.16.21. That'll be the default route. Now that route doesn't exist yet. So if I come in here and say ping 16 20.1. I have no default route, but everything should be in my routing table correctly. So if I come over here and I say show, run interface, or we'll just say show IP route, we should see that the configuration is in there. So 172.16.10, 100, and 172.16.20, 101 or 102. So 101 on left, 102 on the right. Show IP route, make sure everything's good to go. And it is. So obviously we don't have or should not have reachability right now. So let's go ahead and give this a try. I'll say ping 172.16.20, 102. And we should find that we have no reachability. Let's go down to the spine and take a look at what's going on. So I'll say NXOS 1, 2, 3, 4, 5. And all I want to do is show BGP layer 2 EVPN, and we will say summary, and we should still be peered, and we are learning information. The problem that we have right now is that things aren't exactly the way I want them to be. So let's take a look at Leaf 102 first. So the first thing is show run, and I'm going to say include, and we'll say VLAN 10, because remember, VLAN 20 doesn't exist here. And VLAN 10 is configured, let's see, we'll say section VLAN 10 instead of include. And there we go. So we've got VLAN 10. It is configured as a VNI segment. We do have the interface. So if I say show run interface Ethernet 1.7, we'll see that's where that switch port access is. Show run interface Ethernet 1/7. And there we go. So these are things that I need to change. So what I'm going to do is I'm going to say config T, and I'm going to say no VLAN 10. I'm going to go to interface Ethernet 1/7, and I'm going to say switch port access. We'll say VLAN 20, and then I'm going to say VLAN 20, and then I'm going to give it a VN segment of 10020, and I'll go ahead and just give it a name like we did before. I'll just say test VLAN, and I'll just say 20 over here. Now, looking at the other side, we should have everything that we had before. So if I do a show run interface Ethernet 1/7, that should be configured in VLAN 10. That's not going to change. If I do a show run pipe section and I say VLAN 10, we'll have the configuration in here. So that's going to be the VN segment. And just as a verification on the other side here, let's go ahead and just say show run, and I'll just say pipe section, and we'll say VLAN 20, just to make sure that it's configured properly. And it is. Now, I said that since I want to get information from VN segment 10010 to VN segment 10020, I have to route. And what I'm going to do is I'm going to go ahead and I'm going to create a VRF to be able to accomplish that. So I'm going to say config T, and I'm going to say VRF context, and I said that I would call it tenant 77. And again, I'm trying to get as close to terminologies that we're going to use in ACI, so that at least when we're talking about things, we're talking about apples and oranges, if you'll excuse the expression. So we know what we're talking about. So if we're talking apples, we should be talking apples. We should not be talking or using different terminology. So right now, a VRF is a routing context, same as in Nexus, same as in ACI. And we're going to rely on this routing context to give us the ability to be able to communicate between resources. But remember, I said it needs to be a layer 3 VNI. And since it's going to be a layer 3 VNI, I need to give it a VNI number. I'm going to give it 10077 based on my conversations. And it's going to need a route distinguisher. I'll just go ahead and say make that up automatically. And I want to support the IPv4 unicast address family. And in here, I'm going to need a route target. So I'm going to say route target, and I want import and export at the same time, and go ahead and do that auto. But remember, we're using this using EVPN. So it should stand to reason that I'm going to also want to have a auto EVPN set of route targets. And that should push me to the edge here. So what I'll do is I will say show CLI history unformatted. I'm going to grab that configuration, and I'm going to use the exact same thing over on the other side. And I'll just go ahead and paste it in since it's already done. And now all I want to do is verify whether or not that tenant is in existence. So I'll say show VRF tenant 77. And sure enough, it was given VRF ID 3. And over here, if I do a show and we say VRF tenant tab complete, we're going to see that it's running here. Now, remember we talked about the fact that I'm going to need sub-interfaces, not sub-interfaces, SVI interfaces with specificity. And I want these interfaces to actually take part in the VRF. Now, in order to be able to do that, what I'm going to do is I'm going to go ahead and create the components that I described. Now, if I go back to my drawing, so if I go back to my theoretical conversation and I take a look at the layer 3 configuration that I have set up, what we're going to find here is I want to actually build this layer 3 VNI. And that layer 3 VNI is going to require common resources that are going to have to exist on both sides of the equation. Now, I think I have a better drawing. Here's my original drawings. So yes, so this is the one I'm talking about. I need to build this layer 3 VNI. And to build this layer 3 VNI, I have to have a common layer 2 construct on each of these devices. The device or the construct that I'm going to use is going to be VLAN 77, and that's going to make things pretty straightforward in my config. So that's what I'm going to do. I'm going to come into each of my leaves, leave 101 and leaf 102, and I'm going to create VLAN 77. That is going to, I'm going to go ahead and give it a name. I'm just going to say it's going to be part of tenant 77. And then I'm going to give it a VN segment, which a VNI, if you will excuse the expression, is going to be 10077. Do the same thing over here. So it's going to be config T. It's going to be VLAN 77. Then I'm going to say my name is going to be tenant 77. And I'm going to assign it that same VN segment, because remember, this is going to be the connection between leaf 101 and leaf 102 that's actually going to carry the traffic between VNI 10010 and 10020. And keeping in mind that now that I have this VNI configuration, what I also want to do is I want to make that SVI interface. Now, this will look a little strange because I'm not actually going to assign it an actual IP address. I'm going to come in here and say that I'm going to use interface VLAN 77. And what I'm going to do is I'm going to no shut it. I'm going to need to make my MTU as big as possible. So I'm going to say MTU 9216. That's going to make it support jumbo frames. I'm going to make it a member of the VRF of tenant 77. And all I'm going to do is I'm going to enable the feature of IP forward. So enable IP forwarding on this interface. So what it receives is just going to forward. So that's all I'll do. I'll say enable IP forward, and we should, at this juncture, be good to go here. So I'm going to say show CLI history, unformatted, and I'm going to grab that configuration, and I'm just going to put it into the other resources. So we've already built the VLAN, so let's go ahead, or the VLAN and the config. Now what I want to do is configure the interface over here. So all I'll do is just paste that in. And we've already carved up our TCAM from the previous lab. So right now, we've got the majority of the moving parts that I need. So actually, we've only got about a third of the moving parts that we need. So if I come in here and I say show run interface VLAN, and I say 77, we can see the configuration it's set up. It should be functional. I'll say show run interface VLAN 77, and then I'll say show IP interface brief, and we will say VRF tenant 77, and you're going to see the interface. It says VLAN 77. It says it's forward enabled, protocol up, link up, admin up. Everything seems to be good to go. I'll do the same thing here. I'll say show IP interface for VRF tenant 77. I'll need to see brief. Show IP interface. Left the brief off the main portion, so brief. Okay, so notice we're forward enabled, protocol up, link up, admin up. All right, so now the other part of this that's missing, remember, it's the NVE interfaces that form the peerings. So if the NVE doesn't know anything about VNI 10077, it can't work with it. And it also doesn't know anything about the routing context. So if I say show run interface NVE1, what we're going to find here is it's just basically behaving the way it's always behaved. Come over here and show run interface NVE1, and what we're going to see here is this interface right here. It hasn't been changed. So I forgot that. So let's go ahead and fix that right now while we're thinking about it. I'll come over here and say we'll say interface NVE1, and I'm going to say no member VNI 10010. So I'll just paste that in. And what I need to do is make it a member of VNI 10020. And ingress replication protocol will be BGP as it was before. All right, so now let's see what we got going on here. So there's just a few things I want to check to make sure I didn't screw up. So I'm going to say show spanning tree for VLAN 20, just to see if it's running on Ethernet 7, and it is. And if I do a show run interface NVE1, I can see that now I'm properly configured for VNI 10020, but I don't know anything about the VRF that we configured, nor do I know anything about VNI 10077. So that's what I want to change next. So all I'm going to do is I'm going to come in here and say config T, interface NVE1, and all I'm going to do is I'm going to add the VNI. So I'll say member VNI, and it's going to be 10077. But what I want to do is I want to use the keyword here that is going to be to associate the VNI with a VRF. So all I really need to do is put in associate VRF and hit enter. Because remember, there's only one VNI. That VNI already exists in the VRF, so that's going to be common knowledge. The system is going to know which one, because we're talking specifically about VNI 1077, and this is going to be the way that I'm going to create my layer 3 VNI. If I go over here and do the same thing, interface NVE1, and we take a look at NVE1, again, all I'm going to do is I'm going to say member VNI 10077, and I'm going to say associate the VRF here. So let's take a look at our commands as far as verifications. So I'm going to say show run interface, and I'm going to say NVE1, and we should now see the fact that we have the member VNI 10077, and over here I should have the same thing. So didn't mean to do that. Exit. So over here I'll say show run interface NVE1, and we have matching config. In fact, let me log back in here, admin NXOS 1, 2, 3, 4, 5, and I'll just do the show command one more time. Show in interface, show run interface NVE1. So matching configurations on both sides. The only thing that's different is the layer 2 VNI associated with each of the individual resources. Now, the only thing that's missing is the gateway of last resort, because remember, I configured a resource over here. So if I go into H4 and I say in and I say ping 172 and I want to ping 16.10.1, I don't have any reachability because that interface doesn't exist here. That interface has to act as my gateway. I want it to be an anycast gateway, and it needs to be inside of the VRF in order to do its job. So what I'm going to do is I'm going to create each of those. So I'm going to come over here. I will say config T, and I'm going to say interface VLAN 10. Remember, it's 20 on the other side. It's 10 on this side. And I'm going to say no shut. I'm going to say VRF member of tenant 77. I'm going to give it that IP address of 172.16.10.1.255.255.255.0. And I'm going to enable fabric forwarding, and I'm going to specify the mode of anycast gateway. These are all things that you just need to remember. I mean, this is something that you're just basically going to have to commit to your memory. And I'll come in and say show run interface VLAN 10, show interface VLAN 10, and see if that interface is up, if it's operational, and how it's configured. We see here line protocol is up, auto state is enabled, VLAN 10 is up. We see a SVI MAC address has been assigned, and if I say show IP interface brief for VRF and I say tenant 77, we now see that it is configured here. It's operational. Now, all I want to do is know if I can ping my gateway. So now I'm going to say ping 172.16.10.1 from H4, and let's see if my ping goes, and it does. Now, the next part of this is going to be over on the right-hand side. Remember, we're using VLAN 20 over here. So all I'm going to do is I'm going to say config T. And we've already done the configuration for the NVE, so the only thing that is going to be necessary is to create the VLAN 20 interface. I am going to say no shut. I'm going to make it a VRF member of tenant 77. Hold it. Oh, sorry. I already made VLAN. I meant to say interface VLAN 20. And then I will say no shut. I will additionally say VRF member of tenant 77. I'm going to give it an IP address of 172.16.21/24. And I'm going to go ahead and do the idea of the fabric forwarding. And I want to use mode. And you'll notice your mode here, you only have the one, anycast gateway. So it's basically the way you're doing it or not doing it. And with this being done, all I want to do is now verify. I'm going to say show IP interface brief for VRF tenant 77. See if I have my interfaces. Everything is up and operational. So anything that is going to come into this is actually this tenant we've created is actually simply just going to be forwarded. Now, the reason that this is going to work is because, remember, it's the NVEs that we use to form the peers. The last thing I want to do is make certain that I can hit my gateway. So I'm going to come in here and I'm going to say ping 172.16.20.1 and see if I can actually hit my gateway. Now, the only thing that is going to be left at this particular juncture is to see if I can actually ping across. And again, what I want to do is I want to be able to verify what's going on. So let's take a look at what we have now. I'm going to say show BGP. I'm on the spine, and I'm going to do show BGP layer 2 EVPN, and I'm going to do my summary and see if I'm learning information from my neighbors, and it seems like I still am. Let's take a look at the show layer 2 VPN EVPN to see what is actually being advertised, and we can see here that I am learning about CCIE, and I am learning about Cafe as far as the configurations go. And if I take a look at my control plane before I do any traffic testing, let's go say show NVE VNI, and I look at my control plane here, notice that I have the NVE is the same, because remember, it's the NVE that's acting as the VTEP. So it's going to be the source and destination of the tunnels that are going to be extended. And I'm going to come over here and do the same thing. I'll say show NVE VNI control plane. And what we see here is I have a layer 2 VNI for bridge domain of 20. And I have a layer 2 VNI for bridge domain 10 over here. But I have a common 10077 VNI that is a layer 3 VNI that is actually providing services for tenant 77. So the only thing that is going to be necessary now is to see if I can ping across. So I'm going to say ping 172.16.10.101 and see if I can ping between my resources. I am going to do a show IP route just to make sure I didn't ping the wrong address, which I didn't, but see, I am 102.20, so 20.102. And let's do a trace route. So I'll say trace route to 192.168.10.101 numeric, and let's see how it goes. And what we're going to see here is it's trying to navigate out. So 172.20, it hit there. And let's make sure, did I mess up? So let's stop this and see if I can get my trace going. So I pinged show IP interface brief just to make sure. So 172.16.10.101. I have reachability. Let's go ahead and check it the other way. So ping 172.16.20.102. I've got reachability. Let's try the trace route. So I'll do a trace route to 172.16.20.102 numeric, and let's see what's happening. And this is what I was expecting to see on the other side, thinking maybe it just needs a little time to percolate here still. But what we see, I would have expected to see the same thing here. We see that it's actually going to 172.16.10.1, which is my gateway of last resort on my leaf. From there, it's actually getting routed to 172.16.21, which is running on leaf 102. And from there, it's actually being delivered to 172.16.20.102. Now, I don't know what's going on with this guy as far as why the trace routes aren't working, but I do have reachability. So ping 172.16.20. Let me ping my gate. I'm going to ping 10.1. Now, this is actually pinging down and hitting the SVI on leaf 101. Let's see if I got reachability to it. And I don't. Let's try 101 one more time. I have reachability to it. The problem is I'm not learning the prefixes for that. So let me take a look at show IP route. Make sure I got my gateway of last resort right. So 117, so ping 172.16.20.1. I got reachability to it. So from here, can I ping 172.16? I'm going to ping over to 10.1 NVRF tenant 77. Let's see if I've got the reachability in there. And what we'll find is that I do not. And the problem here is the reachability, the sourcing information. So with regard to what's happening, I have the capability of being able to ping across. So I can ping to 10.101. So I'm hitting leaf to leaf, and that's what the task was. If I take a look at my table here, let's go ahead and take a look at my route type. So let's take a look at route type, and you can see here I can go through 1 through 6. So I'm going to take a look at type 2s, which are going to be the mappings towards my MAC addresses. And we see here that I'm learning that MAC address, and that MAC address is reachable via 172.16.10.10 And I'm finding that interesting. So show IP interface brief for VRF tenant 77. Nope, I used one. So 172. This is part of the dynamically assigned route target information. And we see that CCIE, which is going to be this guy up here, is 172.16.20.10. It was assigned to it. So it's not an address. It's part of that automatic arrangement. We can see the extended communities that we have that we're dealing with. We see the MAC address is an actual encapsulation is 8. Router MAC is 5000 and ends in 7. So that's going to be this guy's MAC address over here. So if I say show MAC address, actually I got to say show system internal layer 2 forwarder MAC, and that'll show me my MAC addresses, and we see here the IM7. So yes, it's being learned from Leaf 102. So I'll have to poke around and take a look at what's going on. I may just need to restart this switch right here just to see. But as far as the task was to be able to ping between the hosts using this logical construct that we just put together called my layer 3 VNI, which is visible through the show NVE VNI control plane output, and we see specifically that it's doing the job that we implied for it to do on both sides. All right, so I'm hoping that this helped with the explanation. Again, if you think of it in context of the fact that we have these disparate layer 2 infrastructures, whether we're talking about the VLANs 10 and 20, or whether we're talking about the VNIs 10010 and 10020, it stands to reason that all I'm doing is I'm putting a routing construct between them. And just like we do in the ACI, it handles it for us, but the ACI creates these virtual routing and forwarding instances. And then what we choose to do is we choose to advertise prefixes into those. And we did that through the use, deployment, and creation of these SVI interfaces that I just walked you guys through as far as a demonstration. So I wanted to wrap up this portion of the EVPN. And later on, I'll introduce some additional concepts like multi-homing and things along those lines. But we're going to use this later on when it comes to trying to interconnect to our ACI infrastructure, possibly from leaves, possibly from spines. So it's definitely something that's worth learning. It's definitely something that I would advise you guys to learn to lab and to experiment with. So with that being said, I'm going to go ahead and stop the recording, and I'll see you guys hopefully in another video. I'm probably going to jump to another topic. Right now, we've got some issues with regard to power in the data center. So I'm waiting to hear back on that, and I'll get back with you guys as quickly as I can. So until then, this is Terry. Good luck studying.